Hi, welcome to Aria's Science Tutorial channel. This is going to be the first in a four-part video series where we shall be looking at the definition of electrolysis. By the end of the four-part series, you would have mastered the basics of electrolysis. Okay, so we're looking at the definition of electrolysis. Okay, now electrolysis is actually a compound word that is made up of the words electro and lysis. Yes, electrolysis is a compound word made up of two components, electro and lysis. Electro is actually connected to electricity, yes. Then lysis is the Latin word for breakdown, yes, or splitting, all right? So if we put these two words together, we can simply define electrolysis as a process whereby the passage of an electric current or electricity brings about the dissociation of certain substances. We're still going to beef up this definition once we add one or two concepts there. Now, the first thing that we need in beefing up the definition of electrolysis is what type of substance are we talking about here? Is it every substance that we can break down by electrolysis, or there are certain types of substances that we shall be interested in here? All right. Now, in the kitchen, we have a common substance which we call kitchen salt. Now, kitchen salt is basically sodium chloride. Sodium chloride, kitchen salt. Kitchen salt is sodium chloride. Now, if I use a spoon to scoop kitchen salt from the container, I will have what I call solid sodium chloride. Solid sodium chloride. So that is one form of sodium chloride. Solid sodium chloride. Solid sodium chloride. Solid sodium chloride. I can put this sodium chloride in a frying pan and attempt to melt it by heating it to a very high temperature of about 801 degrees centigrade. Eventually, when I do this, the sodium chloride will be converted into a semi-solid form, and that is what we call molten sodium chloride. So another form of my sodium chloride is molten sodium chloride. Molten sodium chloride. All right? Now I can get a third form of my kitchen salt by dissolving it in water. That will be called aqueous sodium chloride. Aqueous sodium chloride. Now, what do these three forms of sodium chloride have in common? These three forms of sodium chloride are composed of positive sodium and negative chloride. They are composed of positive sodium and negative chloride. Of course, with some differences. In the solid sodium chloride, the positive sodium and chloride are locked together by a strong force of attraction. In other words, the ions are not free, they are not mobile. However, in the molten or the aqueous form of the sodium chloride, the heat and the water we have used respectively have dissociated the ions. In other words, in the molten form of the sodium chloride, I have mobile sodium ions and mobile chloride ions. The same thing with the aqueous form. Now, in the molten form and the aqueous form of my sodium chloride, where the ions are mobile, they can conduct electricity. In other words, they can allow current to pass through them. Now, in chemistry, substances or chemicals or compounds such as sodium chloride in the molten or aqueous form are referred to as electrolytes. So what is an electrolyte? An electrolyte is a compound in either the molten or aqueous form that can allow current to flow through it. If we now connect this idea with the definition of electrolysis, we will get a much prettier definition of electrolysis as follows. Electrolysis is the process. Electrolysis. Process, okay? Let's just make it better. Process by which the passage of a direct current through an electrolyte brings about its chemical decomposition. Okay, let's go again. The process by which the passage of a direct current through an electrolyte brings about its chemical decomposition. You will have noticed that I underlined direct current. That means you cannot effectively do electrolysis with alternating current. What is the direct current? It is one in which the current flows in only one direction. It's the type of current we get from a cell, from a dry cell. Okay? Now, an alternating current, AC, on the other hand, is one in which the flow of the current reverses itself at regular intervals. Now, the problem with attempting to use an alternating current during electrolysis is that the conductors, the electrodes which bring current in and out, will keep changing. That is, the positive will change to be negative, the negative will change to be positive, and that will mess up the process. So therefore, in order to avoid that, electrolysis is usually done by the use of a direct current. Then it is important to note that when electrolysis occurs, the electrolyte is chemically broken down. Okay? So, basically, electrolysis is a process which in subsequent videos we shall see how it affects or how it has contributed to making life much more interesting and modern for us. So, thank you for watching this video, And if you have liked it, benefited from it, I want you to subscribe. I want you to like it. I want you to share it. Tell others about it, and watch out for subsequent editions. And all right, okay, before I sign out, if there could be comments, there could be questions, please leave it behind in the comment section, and I assure you that we will take time to attend to them. Thank you.